second part of lesson 23. The video cut out, and so for whatever reason, it didn't show up. So, to talk about this a little bit more in detail, you need to realize that with these different trig functions here, okay, these different inverse functions, they're restricted by these set domains that you see up here in this table. Okay, and so all of these values that are given to you here, like the 1/2, the negative square root 2 over 2, the 3, the square root of 3 over 2, those are all x values that need to fall in these respective domains right up here. So if you're looking at the sine inverse and this value falls in between -1 and 1, then you are able to get an answer. Okay, we're looking for the y's. When x is 1/2, on sine inverse, what y value does that correspond to? And in this particular case, sine is bounded in between negative pi over 2 and positive pi over 2. Why, you may ask? Well, if you recall from the previous other video, sine, in order for it to actually have an inverse, it has to be bounded, oh wow, that's really big. It has to be bounded in between negative pi over 2 and positive pi over 2 so that it will pass the horizontal inverse as you see right here in this picture. Bounded between negative pi over 2 and pi over 2 included. Alright? And remember, inverses is when you flip your x's and your y's. So that is why that's important. Now, where is negative pi over 2 located? Well, it's located right here down at 3 pi over 2. So we're not going to use this radian value. We're going to use negative pi over 2. Just like for 5 pi over 3, we're going to use negative pi over 3. 7 pi over 4, we're going to use negative pi over 4. And 11 pi over 6, we're going to use negative pi over 6. And then for cosine, we're going to use between 0 and pi because that's where that restriction is, between 0 and pi. And then tangent negative pi over 2 to pi over 2. If you look again, okay? In order for tangent to have an inverse, you have to restrict it between negative pi over 2 and pi over 2. And that's what you see here in the inverse. Similar with cosine, you have to restrict it between 0 and pi. That's the only way you're going to have an inverse. There. So when it asks you what is the sine inverse of 1/2, it's asking you when x is 1/2 on your inverse, which falls in between your domain of -1 and 1, where in the y values within the range is sine 1/2. Well, if you look, sine is your y coordinate. So for all of these ones that deal with sine, we're looking at our y coordinate. So where is the y coordinate positive 1/2? Well, that's right here at pi over 6. So this value is pi over 6. Basically, we're doing the opposite that we were doing back in lesson 19. Instead of you guys giving me the coordinate, you guys are now giving me the radian measure, and I'm giving you the coordinate. Let's look at the next one. Negative pi over 2. Negative square root of 2 over 2. Well, negative square root of 2 over 2 is right here. Or at least it's where the y value is negative square root of 2 over 2. And that corresponds to negative pi over 4. Remember, it's not 7 pi over 4 because our range is in between negative pi over 2 and pi over 2. That's why it's a negative pi over 4. Now, sine inverse or arc sine of 3, well, if you look, 3 does not fall in that domain of -1 to 1. So that means there's no solution for this particular problem. Arc sine, remember that's just the same thing as saying sine inverse of 3 over 2. Well, 3 over 2, that y value is located right there at pi over 3. So that's our value. And we just repeat the same process. Don't let this one trip you up. You have a -2 pi. Well, -2 pi does not fall within that domain of -1 to 1. So here is another no solution. Lastly, for the arc sines, we have -1. -1 is included. There was a bracket here. And so where's that y value -1? Right there at negative pi over 2. And that's how you find the exact values of these inverse expressions. Now cosine is x. So now we're looking at the x values that are bounded between the domain negative 1 to 1, but this time the range is from 0 to pi. So we're looking at our normal unit circle, no negatives at all. Okay? So where is cosine of negative square root of 2 over 2? Well, that's right here at this value, which corresponds to 3 pi over 4. And that's our answer for this one. I'm going to do one more cosine one so you guys can see it, and then I'll do one tangent one so you guys can see it, and then I want you to finish the rest of these off, pause the video, and then press play when you're ready to check them. Okay? So here's the chart again. Just as a reference, we're going to do this one right here. This should say arc, an extra C, missing a C there. Arc cosine of negative 2. Remember, that's the same thing as saying cosine inverse. And so we have to look at our domain, make sure that negative 2 falls in our domain. And if you look, it doesn't. So there's no solution for this one. Okay? So you'll pause the video to do the rest of the cosine ones, and then we're going to do this tangent one together. Remember, tangent is y over x. So we're looking at y over x. Which combination of y's and x's are going to give me negative square root of 3 over 3? Well, tangent, it could be any x value there, okay? And you're trying to figure out, when you're trying to figure out the tangent inverse, you can plug in any value for x. But the thing is, I'm still bounded between negative pi over 2, which is located right down here, and positive pi over 2, which is located right up here. Remember, this is negative pi over 3, negative pi over 4, negative pi over 6, so on and so forth, okay? Now, in order for tangent to be negative, it can't be anything in my first quadrant, because my x's and my y's are both positive, and a positive divided by a positive is a positive. So it's going to have to be one of these negative values between negative pi over 6 and negative pi over 2. In order for my y and my x to simplify to give me a negative square root of 3 over 3, I'm going to need my y value to be negative 1/2 and my x value to be a positive root 3 over 2. The reason why it works that way is because if you keep, change, and flip, your 2's will cancel out, leaving you with a negative 1 over the square root of 3, but you can't have, so you have to rationalize. And that's why it has to be this particular combination. And the only combination that gives me that is negative pi over 6. So all I want you to do is I want you to pause this video, I want you to do I, J, K, L, and N, and then press play when you're ready to see the answers. So here are your answers in the purple for I, J, K, L, and N. Hopefully you guys got this. If you didn't, make sure you bring your questions to class with you tomorrow.